Hello, welcome. This is the talk on effective APIs. So if you find yourself in the wrong room, feel free to go check something else out. One thing I wanted to mention right now, Dick Wall is also giving a talk, and we're having a little competition. Whoever gets the most amount of tweets wins, and the other one has to buy the other one a beer, if that makes sense. So please tweet so I don't have to pay for beer. All right, thank you. All right, so this is a talk where we're going to talk about how to design APIs in Scala. So there's going to be a few sections to this. First off, how many of you guys are application developers, make end-of-the-line applications? Okay, the first part of this talk is going to apply a lot to you guys. How many of you guys are exposing libraries to other people in your organization? The second part of the talk is going to apply a lot to you guys. Finally, how many of you guys are applying Java APIs that other people need to consume? Okay, there's a little bit for you guys as well. All right, that comes at the very end. So just so you know, that's kind of how this talk is kind of segmented. I am Josh Suereth. I'm the author of Scala in Depth and the co-author of SBT in Action. I'm the automation and build lead at Typesafe, and generally just nerdy about anything, from like fish to programming languages. So, all right. The key thing that we want to do in our APIs is keep the intention that we have when we write the API with the user, okay? There's an intention, there's a problem we're trying to solve. We want to solve just that problem, okay? So, in this, types tend to be useful. If I am designing some sort of data store for my application where I get user click information, then I want to do some statistics on it to run business calculations, I could have an API like this. But when I write code like this, it doesn't really have a lot of meaning. Like, I don't know what click info is, and this calculate statistics is really sort of arbitrary. There's a lot left here to want to figure out. To figure out what that code just did, we go and we look at the documentation. Instead of looking at the documentation, since I'm an SBT guy, we just go look at the source code and look at the docs in there, because, you know, that's better. I don't know. Anyway, so here we're looking at the API for the method, and it says returns the mean, median, and standard deviation in a sequence. Okay? So we're going to get a sequence with the mean, median, and standard deviation in it. That's actually that's okay. Now we know what the API did. Okay? So we know we're going to get this sequence. There's a mean, median, standard deviation. So that's what we named our variables. But as a consumer of this API, I have a few questions. Primarily, what is it and how do I use it? Okay? Anytime you give me something, what is it? How do I use it? So mean, if we go back, this is a sequence of double. So mean is a double. Well, let's look at what is a double. A double is the IEEE 754 double precision floating binary point thing. Okay, it's a binary number. Here's the representation. I just learned all about doubles. But how do I use that? Right? What do I use this double for? The basic operations of double are like addition, multiplication, subtraction. Okay, cool, I can add stuff. That doesn't really tell me how to use it in the domain of my API. So all we have right now, all we know is that it's a double. That's pretty generic. Another thing that's nice about having like explicit types where you annotate them here, it's kind of a documentation aid. Even Ruby, when you read their documentation, tells you types. Everybody cares about types, right? If you, in the Ruby docs, you want to know what you get back, and that should give you an idea of how to use it. But again, they still use these weird types, like integer, when you call delete. You get an integer because you call delete on a file. You want to add that with the other integer you get when you delete a file, right? Everybody? Okay. The other thing that's important is that it's not just the type that's useful for discovering an API, it's the name. So if I name the thing mean, when I go on Google and I search for what mean is, I get something reasonable that will inform me about the domain of this API. I can self-discover. Also, just so you know, mean is a JavaScript framework. So everyone take a shot. We just hit a JavaScript framework. Okay, so yeah, types and names. That API I first showed is a terrible API. You know, it has a lot that you want to improve on it. The questions you should ask yourself when you design stuff: how do I know what a good name is for local variables? Am I forced by your API to read Scala doc? How many of you guys immediately read Scala doc before you start typing in an IDE? Okay, how many of you like me and you just press dot and then like anything that shows up, you're like, oh, this looks good, let's call it. Okay, yeah. Since your users are doing that, you need to design with that in mind. That's the way that you are going to give a nice API that they learn via that mechanism, okay? That's unguided learning. So the types and things that they see when they press dot are the things that they will then go search for. So if you use names that they cannot search for, it won't work. So this is a reason why people get really frustrated with symbol operators, because they're really hard to search and learn what these things do. And when they show up in that list, you're like, what is this fish doing here? I just wanted to combine these things, you know? Okay, so let's start improving the types. The first thing we can do is we can, instead of returning raw doubles, we can create a class called ClickStats that has mean, median, and standard deviation in the class. And now I have a name that's associated with the type, and I can kind of guide people on how to learn about that thing. Okay? The other thing I can do is I'm in a statistical world. Okay? Once I start returning statistics, there's this notion of expected value in statistics, and this is a terrible API. I know it's terrible because it's the first one I've written. But here's a terrible API for statistics that I could expose instead of double, where the mean, median, standard deviation are kind of part of the API, and then I can start showing you inside of expected value how to combine and rearrange expected values. Okay, because if you're using a statistics API, most likely you're in a statistical mindset, and you're going to be doing statistical things, and eventually you'll drop down to something as raw as double. Right? Double is like the lowest machine layer, and we don't want to drop down to there for users until they really want to. Give them the escape hatch, but don't force them down there. What's interesting about this is as soon as we start returning this expected value type, we can design, combinators and APIs around how to interact with our return value. So for example, we could have like a normal distribution and a Poisson distribution. I'd probably mispronounce that because I'm American. And then you can add these two things together and get something else back, right? That plus is semantic about statistics, and it does a little bit more, and you're helping your user start to understand the domain. I can actually ask questions like, what operations should I allow a user to do on mean? Which ones make sense? And which ones should I force them to go through an extra layer to kind of encourage them not to do it, right? Not that you don't want them to do it, just you want to encourage them not to shoot themselves in the foot. You should always let users shoot themselves in the foot. I totally believe in independence in that fashion, right? There are times where you need to go bare metal. But you should try to encourage good behavior, okay? The other important question is, how do I interact with this? If I get back a double, there are a set of interactions I know about, but I don't really understand the domain of statistics yet. This can actually help guide me through that via methods, documentation, that sort of thing. The other thing we can do is prescribe good usage. Okay? So if I have a data service API, I don't know if you guys have seen something like this before, where there's an explicit method to connect to a service, and then an explicit method to close, and then there's a method to get data out of the service. These two methods here are uniquely tied together. If I'm already connected and I call connect again, what happens? If I call close and I'm not connected, what happens? If I call get click data, but I haven't connected yet, what happens? Right? This API is not very cohesive, and it's very, 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 very stateful. But it's not necessarily the state that's the problem. It's that I've given you an API that really lets you destroy yourself. Here's an example, not the best, but an example of how to get around that. We limit the API to the portion that we want users to use, and then those two methods that were tied together, we find an alternative mechanism of allowing you to gain access to a data service such that the open-close semantics are captured in the API, and you can't get it wrong. So here, we create this with data service method, right? It takes in the URL string again, and it would call connect, run your function against data service, and then call close at the end. This is known as the loaner pattern, which isn't about being alone. It's about giving something to someone. So like a loaner car, okay? And this is one way of doing it. You can also use phantom types to prevent people from calling types, on the signature. But generally, when I'm making an API, I generally try to stick to things that, like, if you need to fix it at, say, 2 p.m. or 2 a.m., I should say, like after you've been out all night partying with people, you should be able to, like, fix a critical bug. So some of these core APIs, you don't want to get particularly fancy, but still, those are valid use cases, all right? Anyway, this is the key solution here, was the fact that we lifted this into a higher order method. The other thing you want to care about when you give types to somebody else is error handling. And we're gonna fragment error handling into 3 classes, because I don't think people really focus enough on what error handling is and what it means, okay? In Java, most error handling is exceptions. Almost guaranteed, almost everything is done with exceptions. In Scala, well, we have this weird story. So let's focus on that. The 3 types of errors you have are recoverable errors that your software can recover from, that you know how to do. Generally, we throw up our hands far too often when it comes to errors, but it's still good to identify the ones that you can handle. It could be you can't. Then there are recoverable errors that your users will need to take care of when you design an API. You need to make sure you give them enough information to recover. If all you do is throw an exception, you're really doing them a disservice, if it's something they can recover from. Finally, there's unexpected errors that you just aren't aware that they're going to happen, and your users won't really know how to handle. So this is where you kind of throw the exception and escape out, all right? But let's look at some recoverable errors. Here's an example of a user privileges API. Someone logs into a website, and you want to get what privileges they have to access the website. So it's a service to look up privileges. I'm just hiding this behind an interface, okay? What I'm returning right now is an option of privileges. So if I look up privileges and I don't find any, I give you back a none. And if I find privileges, I give you back a some. How many of you guys have done this, right? Okay, so I'm going to say here, try not to do that. All right, now why? I'm forcing the user to handle the failure, but maybe my subsystem actually should own it. What if I use, this has a terrible name because it has the N-U-L-L 4-letter word in it, but it's called the null object pattern. If I create an object called no privileges, which extends privileges but returns nothing, right? For anytime you say, do I have privileges? This is a far better way to return that error case. I've recovered it for the user. Okay? So when you're returning things, think about this really intensely. Is it core to your API that the user handles the fact that there's nothing there? Or should you be using this pattern instead? Right? This is me recovering for the user. So if the user needs to be aware of an error, and the user has to figure out how to recover, that's when we would send the option down. All right? That's how that goes. The case where this normally fits in that I've seen are things like data validation. So they give me some data, and I'm going to validate their input and then send them all of the failures so they can fix it. Or things like unavailability, the network's down, the database is down, that can be reconnected, but they need to set that up, that are outside of my system. Okay? Or retried. These are kinds of like recoverable errors. So what I actually recommend when you're doing this sort of thing, a lot of people are arguing about whether to use try, whether to use option, whether to use either. I'm not going to recommend either. Throwing that out there, not either. I actually don't recommend using try for this case. The reason why is when you're doing these validation bits, you actually want to recover all possible errors many times and return all of them to the user so they can repair them all at once. Example, a user submits a form or submits some sort of online thing that they want, and you're going to look at what they gave you. You're going to find all of the errors and give it back at once because the validation logic lives on the server instead of the JavaScript. Well, if you're doing reactive design, you're going to get a lot of that validation logic in the JavaScript and duplicate it in the server, but that's a different story. The key here is you want to send all the errors at the same time. The worst user experience is I give you something, you give me one problem, I fix it, I expect it to work, but instead the second problem shows up, right? You don't want to do that. Similarly, as an API user, I don't want to send you data and get back an error, and then, okay, recompile my code, send you data, get back a new error. I want you to give me everything that you know that's wrong, if you can, at that time, okay? So what I'm recommending, right now, Scala Z validation is kind of the best kit on the block. There's one from Scala Test, which I think is pretty good, and we use one inside of Activator, which, well, I wrote it, so I can't recommend it. But yeah, it's a, what you're actually doing with these things is there's a notion of zipping together errors and recovering from them all at once, okay? But when you do this, a lot of people that pick up Scala Z validation are picking up Scala Z validation NEL, which stands for non-empty list. Giving someone a non-empty list of, say, string or exception is just as bad as not really giving them a semantic error at all, relatively. You want to actually pick the type of your error and give them a semantic error that has meaning. So if I have, say, like I have an error that comes from getting it from a database, and say my service is pulling from 2 different databases, like Mongo and Redis or something, in this case, I want to make an error type that actually captures which system was down, okay, to know what to retry and to know what to do. You want to actually lift some knowledge into these things. You can also provide other mechanisms for people to send you information to recover, but if I am responding to someone and saying something was down, I need to give them enough information. And using a semantic, your own custom designed error trait is actually the best practice. It's the best way to get legitimate errors and be able to recover from them each time. Okay, 2 more, sorry. That slide should have been deleted, but yeah, I was too busy laughing at the last presentation. All right, the next thing that we come across are unrecoverable errors. We have no way semantically of figuring out what happened, really. These are things like out-of-memory exceptions. These are things like stack overflows. Not being able to connect to something sometimes comes back as a semantic error because the exception's thrown somewhere else. Your only option here is to escalate. You cannot handle it, and you can't even provide the user an efficient way of handling it, so you escalate somehow. Here is where you use try. Here is where future helps. Here is where sometimes just calling system.exit is the correct thing to do. And here is where the actor error channel really comes into place. This is where actors can restart the subcomponent that died. Okay? You actually, sometimes, like with actor systems, you need the error to go 2 directions. For example, if we go back to this to-do, which I was supposed to write, the validation custom error thing where we have a custom data error, if that's inside of an actor hierarchy service, and this database is down and that one's down, I might want to report out of the service to the consumer of the API which service is down, so it shows up in a log file over there, because that's where I'm going to look first when this thing isn't working, and let akka try to recover the service. Right? You might actually need the error message to go 2 directions. But unrecoverable errors are a separate error channel from API usage. These need to be fundamentally different. Okay? One is going through the lexical scope of your code, things you call, and the other one is what you do with serious system issues, serious things that need to be recovered, and generally your lexical scope won't know what the heck to do. And yeah, system.exit is a very legitimate way to handle that, especially given modern architectures where we just reboot JVMs and machines. Again, how you handle it really depends on your use case. If you're the IDE and you call system.exit on exception, I don't know if people will be happy, but you can try it. All right. So to recap, like basic API design things, just principles, your types need to be descriptive. The type name that you choose should help people self-learn the API. Trust me that if you don't use a type that just makes sense to people, you will have to explain it to every person who pulls in your API in your company. Names should also be descriptive, and this is where it gets really hard. If you can't use a descriptive enough type, then you need to use a descriptive enough name, because they both combine to help people discover things, especially given that the common way of learning an API is pressing dot and tab, okay? And finally, types need to be cohesive in that when I have this type and I have that type in my API, they should kind of work together and prescribe correct usage between them. I should try to disallow bad usage, okay? And then I need to enforce errors to my users. I need to actually give it to them, not as an exception, but as something they can handle and recover from, okay? That's like the key of basic API design. And then we kind of get into the real ugly bits, which is I have a jar that I want people to use, and I want to issue patches to it. I want them not to have to recompile their code and pull in my bug fix jars. This is something that a lot of library authors and things in the Scala community do. This is something you might have internal to your company, depending on your deployment mechanism. If you're not recompiling things all the time, this is really relevant. If you guys recompile all of your source code all the time, I'm really happy that you can do that. I wish I was in that world, and you don't have to listen to most of the next bits, okay? So, basically, users have expectations. If they're using SBT 0.13.1 and they pull in SBT 0.13.2, everything should work. So, methods you call should never disappear, and you should never see some weird Stack Overflow thing. The problem is that as a developer, you want to improve things. I want to expose additional information throughout the API. I might want to take an API that was poorly designed and start reducing visibility. And there are means that you can do that and keep binary compatibility, which are fun. And you might want to rework a whole subsystem because you've realized it's not well designed. You want to change that whole thing. And you want to do so without affecting the health of the total system. Okay? How many of you know whether or not this is binary compatible? I take a case class with a user that has a name, and I take another case class or change it. I add a new parameter, passphrase, with a default parameter. Okay? So I can still call new user, or I can call user with name, and that still compiles. Is this binary compatible? How many would say yes? Raise your hands. Okay. Sorry, it's actually not binary compatible. If you wanted to make it binary compatible, this is your problem right here. You added something new to the constructor. So you have to make a forwarding constructor from the old one. Not only that, equals and hash code change because the new parameter actually participates in equals and hash code. So if you have any sort of serialized hash maps, they will no longer function correctly. So you have to override them to be the old version. There's also a copy method that only knows about name and doesn't know about passphrase. So it has one argument instead of two. So you have to override this, not be a case class. Finally, you have to implement apply and unapply, so pattern matching and deconstruction work. Generally, you should ignore that because just don't do it, right? If you're using case classes, they're locked. If you want binary compatibility with case classes, make sure you define them well first. There's a set of compatibility no-nos here that if you're trying to make something binary compatible, here are things you can't do. Do not modify the case class constructor. Just don't. Do not add an argument to a method. It's okay to add a new method that overloads the previous one with the new argument, but you can't actually add an argument to the original method. Okay? You can add a concrete member to a trait, except generally, even though sometimes this remains binary compatible, it just explodes at runtime. So it's not really binary compatible, okay? And do not remove anything out of a class. Any sort of public thing in a class member or argument, don't do it. So what we really want to do if we're designing something binary compatible, or in any API development, is we want to remain flexible in our underlying implementation where we can actually make change. Like those binary compatibility things that we can't do really limit your ability to change your library. So what do we do? I mean, here's a set of rules to actually make your API modifiable. First thing you can do is put a lot of things into internal packages. Now, you have this implicit rule in Scala and in the ecosystem that if you're using something in internals package and I break it, that's on you. Right? This is about negotiation. I will maintain anything in this package and keep it stable for you. This other package, if you're using things, it breaks. Quite simple. Another thing that's actually really, really nice and works well with the type class, type trait pattern, is to create a pure abstract trait and then instantiate your implementation in a factory function in the companion object. So users of your API will call do stuff like they do a case class, and they get this pure abstract trait. And then if I want to add a method to the trait, that's fine because everybody is going through this factory function, and I can add it there, and I control both ends of the inheritance. But if they are extending from the do stuff trait and doing their own thing, it's perfectly binary compatible to add a new method that doesn't do anything. That's just what we do in Java. I don't know if you guys followed, old JDBC 3 to JDBC 4. All those interfaces got, a bajillion extra methods, and the old JDBC drivers still work, as long as you don't call the new method, right? But that's the Java ecosystem. That's what binary compatibility means. So we're going to leverage off of that. Okay? So here's the user level API. There's the factory method that lets us hide all of our implementation details and only expose the API we want. Okay? The next bit is you should use abstract classes. If you use an abstract class, the reason to do so is that you want people to extend something that has some base implementation. But an abstract class, you can throw whatever the heck you want in it, and it generally remains binary compatible to add things. You can remove private things, you can't remove protected things, and you're okay. So it gives you a little more flexibility. So we can add do more stuff, and it's just fine because it's an abstract class, and that gets extended correctly. Another fun thing is when I add a new API, keep it package private if I don't need to expose it. If I need to get data throughout my API, I need to add some new feature, but I don't really want my users to rely on it yet because I don't know if I'm going to commit to it, make it package private. So this is private to the API package, is this new method, internal details, that I use to expose details from some service to myself. Okay? Because it's package private, I can call it. It's part of the API, but my users can't unless they put their software into my package. How many of you guys feel like that's evil? Good. That's the whole point, right? But you can still do it. So if a user really needs to get dirty with your API, they can dig down, make it work, but generally people won't. And that's really, really good. You don't want them to. You don't want them relying on the internals, but you needed to expose it across things. So that's another trick that we have. If you look in SBT, there's tons of private SBT all over the place. Another thing is you can hide case classes. So if you need to deconstruct something and you want people to pattern match on it, okay, write the unapply method yourself against an abstract trait. It's unfortunate that you have to do this, so only do it when you really have a binary compatibility reason and your data is something that changes frequently. If your data is relatively locked down, you do not have to do this. Another thing is using overloading. This is the one that really feels wrong, to be honest. Like I really wish that you didn't have this in Scala and that you didn't have this in Java, but Java only really supports overloading as a binary compatibility mechanism. So if you want to add a new argument to a method, the way to do that is to actually add an overload that takes the new argument and pass a default in the previous one. All right? And because you're overloading, there's certain other things you can't do. So one thing that we learned in SBT was basically we don't use default arguments as much as we would wish, and we're stuck using overloads. So again, if you don't have to worry about binary compatibility, don't worry about it. If you do, this is your life. So just a quick, best practices. Don't force people to use binary compatibility unless you have to. Right? I can't emphasize this enough. Binary compatibility is a great thing to keep an ecosystem stable. But you really want it to be a very, very small part of your API that people can build off of. If you design an API, a well-designed API that does one thing well, such as pipes, right, Unix pipes, you won't have to expose a lot for them to use it in very complicated and interesting ways. So you want to make that piece as small as possible. So only a little bit of your whole program works on that. If you look at Unix pipes, what is the API? Well, I have a file descriptor, and I can write strings to it, and I can read strings from it. That's it. If our interfaces were all that simple, we'd get a lot more flexibility, and binary compatibility is way easier. Okay? When you do have to expose something, prefer overloading. Use abstract classes. Use pure virtual traits. That's where there's no equals on the end of any method, or val, or def, or var, or whatever. Well, don't use var. And then final classes. That's another thing that I actually don't mention earlier, but if you make a class final, great. Right? Then people can't extend it, and you can freely do things in it. Only really do that if, it's the bottom of a tree. And then you can expose new methods instead of changing existing methods. Okay? So that's related to the overloading thing. You can just make this method too. Sometimes we have to do that because it's real life and it gets dirty. So you really want to have this minimized exposed library with full library code in it. What gets interesting is when we start talking about Java. This is all of my advice about Java. You can keep your API Java friendly if you make pure traits in the core. Right? 100% pure. You can also use Java interfaces, which is what I do, just to be safe. I don't want to accidentally pull in something that Java can't look at. All right? Use Java types in your Java API. They want to see Java util.collection. You might not want to see it, but that's what the Java API does. And we should let the Java world work in the Java world, keep the Scala world in the Scala world. Okay? Also return primitives. Don't return boxed things. You will still get a lot of fun every time you get a boxed double out of Java. It's not a good time, but just a little bit of boilerplate code. What I really recommend is just create a pure Java API over here. Okay? Create pure Java interfaces, create a Java class with static members that calls into your Scala code for the Java users, because they're not going to want to see $sign all over the place. They don't want to see $sign module. They don't want to see the Scala function interface. They want to see something that looks familiar to Java. And the best way to do that is still to write that in Java and then call down to your Scala. It will actually still be not a lot of Java code because all of the guts are in Scala, but there's still work there, especially when you have to hide, say you're doing something with implicits in your API, that just doesn't show up in Java at all. So generally, it's just better to create a Java API and think about what it looks like from the Java side when you need to work with a series of Java developers. So yeah, if you write it in Java, you'll be in the Java mindset, and you'll be focused on what it looks like from Java, and you'll have to deal with all the pain of the other side. Okay? So I think I just ran through that really, really, really quickly. Like really, really, really quickly. So are there any questions? Yes? Okay, so the question is, are there any tools that you can use to check or ascertain binary compatibility of APIs? Yes, there are several. So there's one from Typesafe called Mima that we tend to use, which looks at Scala things. It still misses package private, and you still have to do some configuration to hide these private internal packages. But generally, it does a really good job. That's what's used for Scala, Akka, Play. There's another tool from Maven that's kind of tied with semantic versioning that will check your API in a pure Java mindset that actually does a pretty good job. And I think it's actually just called semantic versioning. Yeah, I always forget the name, and then I'm like, oh, it's just semantic versioning. So I think it's just called semantic versioning. Any other questions? Yeah, I have. Yes?
You said it is not good to write a method with default parameters, but it would be better to use method overloading. Wouldn't it be a task for the Scala compiler to do this?
Okay, so the question is, would it be better to write... Okay, so I recommend... Questions about, I just recommended to use methods with overloading instead of default parameters. And then the question was, couldn't the Scala compiler make default parameters work and do the binary compatibility thing? And the answer is actually no. The way that default parameters work are that you can specify one or more default parameter. So the way that they're encoded is actually there's a static method for all the defaults that gets called and applied to that position. And you can drop off any number of arguments or reorder them in any fashion. That doesn't work with overloading. Overloading, you can only drop off the last thing. So it's actually far, far, far less flexible. So you're back to the land of Java, essentially, if you need that method to remain binary compatible. Again, you want to have this little tiny piece of API and this big wealth of library when you design your code. And that little tiny piece is where you're stuck using overloading if you need to. So you want to keep as little as possible in there. And this is kind of what Scala did with modularization. We can keep the library nice and small and tight, and then we have these modules. And the modules can actually bump a revision number, which is binary incompatible, and still service the ecosystem. So for example, the Scala XML could have a 2.0 version. They're on 1.0 right now. 2.0 could be a completely different binary compatibility story for XML. But those who need binary compatibility will remain on the 1.0 series. And so the only thing that the Scala compiler and library need to lock down on are this core module. We're trying to shrink that guy as far as we possibly can. Okay? And again, if you don't need binary compatibility, don't use it. Try to avoid needing it. Yeah. Here's another question. Here? So the question is, yeah, so here I have, for click stats, I have mean, which is type double. And the question is, what do I think of using, making a mean type which extends any val? Yeah. So that would be a great idea if you always represent mean as a double, which personally when I deal with statistics, I think you want to deal with distributions to some extent because you always have variance and mean kind of tied together when you look at things. You want to sort of know the variance as well as the mean. So that's where the anyval bit kind of falls down. But in general, if you have an API that just uses a double and you want to expose a new type and you want to enforce constraints on that type, I think using anyval is a great idea. In this example, I think the mean and standard deviation, more actually the median and standard deviation, are kind of tied. So I would recommend keeping these things together in your API because your users will kind of want them together in the API. And that's something you learn, as you go through the API or as you make the design to try to keep those things together. Yes? Oh, primary key. Yeah, primary key is a great example. You could have a primary key extend an anyval where it's a long, and then primary key is its own thing that people know to look up. Yes, that's actually a great idea. Yeah. Right here, I think.
Are there any situations where you find yourself having to kind of fall back on Scala docs to embed some information about your APIs and haven't been able to sidestep it like typesDesigning?
Yeah, so the question is, are there any instances where I've had to fall back on Scala doc to describe my APIs and I can't enforce it in the type system? And that happens all the time. So one thing about functional programming, you deal with combinators. Combinators tend to be outside of the type in functional programming, not something that's a member of the class. So you have this means of combining two different types into a third type. To document that, generally, you need a Scala doc. You need a tutorial. SBT is a great example. We need to improve that tutorial, improve the reference manual, and help you figure out where to find things. That's kind of inherent in functional programming to some extent. But part of that is because when we designed the library initially, we were thinking about these powerful combinations, and I think we could have exposed all of those powerful combinations with the element of discoverability if we had focused on it when we wrote the API. So some of it is just that naturally we don't. So you end up forced to write the Scala doc, and some of it's actually inherent in functional programming that you will have to. My recommendation is, I'm being very strong in that statement, try to push as much as possible on discoverability. Your life will be far simpler. If a user needs to read a doc to understand the semantics, it will take them a lot longer to get started with your API, and you might miss that first experience of like, oh, I get this, let me go learn more. That's kind of what you want when you're encouraging others to learn, your software. Yes, over here.
So when you're testing your code that uses an API, there's a private method, a package private method in it. Do you have any recommendations for how you might work that?
So when you're testing the API and there's a package private method, do I have any recommendation for how to work with package private? The consumer of the API wants to touch my package private thing in their tests. They want to mock the API. Why are they making fun of the API, James? Okay, so this is about mocking. Yeah, the question, I think, if we go back to here, we have a trait. I think it was the next example. Yeah. Something you can extend. Right here. We have a trait here, and there's a private API in there, and someone wants to mock it. If they're mocking it, they're already doing really, really dirty things in your API. They're already doing something dirty. So if you have users who want to mock, I actually recommend giving them something to help them mock, because they are going to have to handle things. Generally, though, if they're using your API and they're mocking, they'll never call that method. So the mocking should just work. And it's on a pure virtual trait. So they never have to mock it. They're only calling the APIs that are publicly visible. So if they mock you, they won't see this. So with mocking, it's generally okay. There are some edge cases, though, where I say you might have to provide something special for the user. If the package private thing is on, say, a static object, and they're trying to mock that, generally I don't encourage that at all. That means there's some fundamental issue in your API that you need to fix otherwise. But that package private, they shouldn't have to actually mock. The way the trait works reflectively, they'd be able to mock. There's nothing wrong with them mocking it, but they won't even have to because they'll never call it. If they try to mock it and send it into your classes, though, that's different. That means they're unit testing with mocking your library, and that's not something they should be doing. What if they are what?
If I send you some service, I can't do that because I can't provide implementation of these private.
So the question is, if you knew some service, you couldn't, call that because it's private. Actually, the way the rules work, if I recall correctly, you can extend it. You just can't call it yourself later. But if you're doing that, just put your tests inside of that package. I've had to do that for many libraries already.
Can you just loosen the private API to public?
You could loosen it to protected. I think you have to. And then the whoever extends that can call it. And that'd be okay. But generally, I don't really. When it comes to mocking, you want to run off of pure virtual traits and these sorts of things. You don't want to mock via extension. Just use a dynamic proxy. And if you really need to reflectively call something, which, as a build tool that happens all the time, there's a reflection way that you can get at any method. So, yeah. I have a library called Evil Monkey, which you can take a look at. You can point it at any class, and then you can call any method or member or field. It's as evil as it can possibly be. Yes, back here. Okay, so the question is about library dependencies. So you have a library A that depends on, or library A with several versions, library B and C that depend on different binary compatible versions here. Then you have library D that wants to depend on both of these. And so you can't actually pick a binary compatible friendly version here because of those two. There was work done, so there hasn't been work done to fix the problem where you just magically rewire things, right? That doesn't exist. There was work done on a resolution algorithm and a dependency management solution called Adept. So Adept's fundamental model can actually create these microcosm universes where, like, every time you make a binary compatibility decision, it restricts all of the libraries visible to things binary compatible with that thing. So that's actually what I'd recommend taking a look at, but it's in its alpha stage. So it's not, definitely look at it. We designed that model to, like, solve that. A bunch of us that got together and thought about it, but it's still an alpha. Yep. And I think that's all the time I have, so thank you guys.